Imagine that you are living inside a huge system. You can measure distances, you can study the movement of objects, you can discover the laws of physics. But there is one problem. You have never seen the structure that makes your entire reality possible. It is so natural to you that you don't even realize it exists. Now, imagine, what if there is not just a thought experiment? What if space, time, and even matter are not the fundamental reality? What if are only the result of something deeper? Today we will explore an unusual hypothesis. What if the universe has its own Webway? When we look at the cosmos, we usually imagine it as a giant container. There is a space. Inside this space there are galaxies, stars, planets, particles. But modern physics has already shown us that this picture is not entirely correct. According to Einstein's theory of general relativity, space and time are not fixed stage where events happen. They can change. Mass and energy can distort space-time. This distortion is what we experience as a gravity. But this raises another question. If space itself can change, could space itself be something that emerges from something deeper? Could space be not the foundation of reality, but a consequence of something else? Let us create a thought experiment. Imagine that there is a deeper level of reality beneath our all. Let us call it the Webway. Not like a science fiction network, not as tunnels beautiful to travel in, but as fundamental structure that exists before space itself. At this level, there are no familiar coordinates, no meters, no seconds, only different states of the structure itself. Just like water. Water can exist as ice, liquid, vapor. It is the same system, but in different states. Now imagine, what if space itself could also have different states? Perhaps our universe is not the only possible configuration. The fundamental structure may allow countless different states. Most of them could be unstable. They appear and disappear almost instantly. But some configurations become stable. They exist long enough. And inside one of these stable states, something extraordinary appears. Space, time, matter, stars, life, observers. In this view, the universe is not necessarily a created object. It could be a stable state of a deeper system. One of the most interesting possibilities is what if particles are not tiny building blocks? Imagine a vortex in the ocean. A vortex exists, it can be measured, it can contain enormous energy, but it is not separate from the water. It is a state of the water itself. If we apply the same idea to the fundamental structure, particles may not be objects existing inside space. They may be stable configurations of the structure that creates space itself. Like a wave on the surface of an ocean, the wave exists. But without the ocean, there is no wave. Now we reach the most important question. What happens when the structure reaches its limits? For example, when enormous amounts of energy become concentrated in a small region. Today we know objects like black holes. But what if a black hole is not simply a place with extreme gravity? What if it is a transition between different states of space? Imagine water. Under certain conditions, it suddenly changes its state. It doesn't break, it recognizes. A transition into another state. If a deeper structure exists, another question appears: where are its boundaries? Imagine creatures living on a two-dimensional sheet of paper. They can study distances, geometry, movement, but they may never see the sheet itself. For them, the surface of the paper is the entire reality. Perhaps our situation is quite similar. We study space-time, but we may never directly access the structure that creates space-time itself. Today's physics has two great theories: general relativity and quantum mechanics. Both are incredibly accurate, but together they create a problem. Gravity is described through the geometry of space-time. Quantum physics describes probability and the states of particles. What if both theories are different expressions of a deeper level? Then quantum effects may not be strange behavior of matter. They may be the result of our reality interacting with a more fundamental structure. But there is one important question: how can we test it? Science requires more than a beautiful explanation. It requires predictions that theory like this would need to show. What new phenomena we should observe, what experiments could test it, how it improves existing models. For now, the Webway of the universe remains a hypothesis. But questions like this are often where new ideas in physics begin. Perhaps the universe is not just empty space filled with objects. Perhaps space itself is an object. Perhaps time is a consequence of change. Perhaps matter is a stable state of a deeper structure. And perhaps the greatest mystery of physics is not what exists inside the universe, but question: why does a structure capable of creating a universe exist at all? We may be living inside a system, studying its rules and understanding parts of its mechanism. But the question of what lies beneath reality itself remains one of the deepest questions humanity has ever asked.